Whether the screen is visible now? See the screen?
Yes, sir.
Now look into these outputs. First of all, so I printed a number. So we can add two numbers using AWK script. So whereas the input is given directly from a stream, directly in the code it is given. So look into the way in which AWK treats these numbers. Particularly AWK treats the numbers. Expressions comprise strings, numbers, variables, and entities that are built by combining them with the operators. AWK does not have character, int, long, double, and so forth as a primitive data types. Okay, there is no differentiation. Every expression can be interpreted either as a string or a number, and AWK makes the necessary conversion according to the context. AWK also allows the user of user-defined variables, but without declaring them. Variables are case sensitive. Remember, small x is different from capital X. A variable is deemed to be declared the first time it is used. Unlike shell variables, AWK variable don't use dollar. Don't use dollar in assignment or in evaluation. Okay. Now in this case, what the first inputted number 10 in the last case, that is assigned to $1. This environment variable. This is not the one is not the value. $1 is the environment variable. For that, 10 is assigned, and you are getting the output in that particular way. Similarly, you can store number in a file also. Now let us create one small text file for that matter. We'll create one small text file called numbers. That I will type some numbers here. 10, 20, 30, etc. And I'm using a VI editor for this particular code. Now, in case if you want to add these numbers, then you can write the numbers are stored in files. You can get a total once again, see like syntax will work. Take one number, continue one number at a time until the end of the file, and go to print total. Name should be and name the input file. Then you will get the output. Look into the way in which, so in the file, if the input file is numbers, there is some numbers, one number in per line. This is a normal text file. Store all the numbers in that text file. Then you can execute that particular script. Note down this particular script here. AWK, within the code, I am writing the code total is equal to total plus $1. That means automatically one number will be fetched from the input file that will be added to the total. Here also you note that we are not initializing total equal to 0. That is not necessary in the context. The moment you use, and you need not declare one variable, whether it is integer, float, character, etc. It is not supporting it. Either all the numbers are treated either as a number or as the strings, depending upon the context. Okay, this is how we can use variables in the code. Look into the program structure also. Within the code, we are going to write all the program statements. If it is variable also, we are writing within the flower brackets, codes will exist, and that entire set of flower bracket is enclosed by a single quote. This is the syntax of using variables along with the code. In a similar way, you can declare, you can type in some other different codes. Say, for example, if you declare x is equal to some issues in that. Let me correct it. So let me go in this particular way. WK. Then if you want to work with the strings, quote it in single, then write one equal to, then you write MIT, and this string should be enclosed within the double quotes. That is the most important in WK. Then another string, if you want to take str2, so you take it within the double quote manipul. Strings are enclosed with the double quote, not with the single quote. Then the next statement, if you want to concatenate these two strings, you say str3 and is equal to str1 str. Then print str3. Then you are going to add that particular two strings. This is how we are going to add strings with the AWK. A code or the program code to add two strings. Note down it. Take down this particular syntax. How we can use AWK to add two strings. Here also the input is given from the stream. I mean in the code directly. We are not taking it from the file. So AWK, then you have to say start. There should be one variable here, str1, and that variable is assigned with the string. A string is always enclosed with the double quotes. Now, if you look into this, within the double quote MIT, I intentionally gave a blank white space. That's why in the output also, you are going to get that particular white space. Suppose I increase that white space further. Say, for example, for the manipal also, if I give some white space, look into the way in which output is displayed. That string manipal appeared with some white spaces before the actual characters. Okay, this is about how to deal with the strings. So what you need to remember here is about how we are going to assign strings with the double quotes. This is very important. In case if you write in the same code, or for that matter, assume that how the context will work. If I say this particular number, or str1 is 5, and str2 is 6. Now, if I say that str equal to str1 and space str2, print str3, 5 and 6 is treated as strings, not as numbers. Okay, because 5 is a single character, 6 is a single character, not numbers. And these two single characters are concatenated, and a string of two characters, 5, 6, is displayed here. But interestingly, if you suppose if you write str1 plus str2 now you are going to get 11. Now by looking into our expression str3 is equal to str1 plus str2, the context is addition. Addition normally requires number. Automatically AWK treats 5 and 6 as numbers. Treats 5 and 6 as numbers, not as characters. This is a very important point to remember. How the context will change. Okay. And suppose one more important point. Now str2 I will write, say for example, one alphabet A here. Now if I treat this as a character, no confusion, you are going to get 5A. 5 is a character, capital A is a character. But now if I write str1 again plus str2, then what will happen? Because by going to the previous logic, number, that string is converted into, the character is converted as number. But what will happen to A? It is not a number. Then that character A is converted into 0 automatically. You are going to get 5. Whatever the string, second string by default will be converted in as equated with 0, not as a string BA. So this is also you need to note. X, so what happened to the number? Okay, that number is treated as a null or else 0. And next we also discussed about how AWK, now our experimental input file is empm.lst. This is our input file. Okay. Now from if you want to process this file, see now why we are doing this. This is very important. Now anyway we have taken one sample file, but our intention is that various applications installed on operating system will create many log files. Now once if you study the syntax of that log file, you can process, you can try to find out what is happened with that application. What is a log file? The moment you install any one application, many of the applications generally record the activities in its own format. All standard applications will store this so-called log file or history file in a separate folder, in a system folder. System administrators can keep a watch of these files and then can try to find out what is happening, what users are doing with that particular machine, etc. They can study. And as well as even in case of any attacks, network attacks, etc., they can, or virus activities, whatever it may be, system admins can watch those log files. There are many different log files are there for Linux. System admins, if you, the point is that you need to study that syntax of that log file, and then you need to know how to process it. Now we are studying the text file. It's a log file is nothing but a text file. It will record every system. Say for example, you are installing a web server. Web server will record all the activities of that particular web server. How many people are logging in a timeline? how many users are logged in, how many are logged out, how many are disconnected in between the sessions, how many are trying to give wrong break password in your system by giving wrong passwords, multiple login attempts. Everything can be tracked, and it is a operating system will automatically record these files in such a text in the form of text files. As a system admin, try to you understand the syntax, and after that write your own script to extract information. Now this is one such file, a sample file. From this we can get various informations from the text file. Now let us try with the AWK. Say for example, now every field is separated by a vertical line or the pipe command. So indicate what is the field separator. Field separator is this line symbol. Now you are taking the third field for each field. If that is vertical line is the semicolon. Third file, third column in that is generally this department. So the third department you can get it with the variable $3. $3. $1 is registration number. $2 is the field called name. $3 is the department. $4 is the date. $5, sorry, $3 is the designation. $4 is the department. $5 is the date of birth. $6 is the salary. Now I am interested in content of third column, that is designation. So $3, if this is equal to string is, say for example, director, or but it's double vertical symbol, $3 sales director. Okay, let me find out for chairman. It correctly. Processing. Then action, you are going to write what to do. Print. Okay, let me print all entire line. Print empn.lst. Look into this output. It prints directors and chairman and their details. Note down this command also. How we can use now $1, $2, $3, $4, etc. will have relevance if you clearly identify what is the field separator. That's why AWK -F. And after that, within the double quote, you are specifying what is the field separator. Then $1 is the first employee number. $2 is name. $3 is the department. Sorry, the designation. $4 is the department. Date of birth and salary. Accordingly, you can process the data file. And now, if I am printing every content in the corresponding line. This print you can further edit it, further customize it. Print you can go for, as we discussed in the previous class, C-like syntax also can be done. See, with it, you can try to print selected fields only. If you are not interested to print all the fields, try to print selected fields. Specify the size. This is minus 20 string is the 20 is the space for printing that particular variable. 12 is the space for printing the next character. Then again, if you are printing that number, so then you write conversion specifier is %d. And then if you want to go to the next line /n, look into this C-like syntax. Formatting, write a comma, then write in the first field you want to print a name, that is a $2. Then you are printing the designation $3. If you want to print their salary, you can say last one $6. This information, if you want to print from that here input file, the command. Something went wrong here, so and close the double quotes. If you're using C-like syntax, remember you write printf. You need to write printf, then you need to write %f, then string name, %-12os, then %d, next line characters, /n. If something went wrong, let me correct it. I forgot to write percentage here. It's very important. C-like syntax. Now look into this output. This is output. Remember so if you miss a percentage here, you will get some -20s, etc. garbage. Conversion specifier is directly printed. That is not a desirable. Now you're going to get the correct result. So syntax is very important, not the C-like syntax. It should not be print, it is a printf. Then double quote. There is no bracket after printf. Otherwise, the conversion specifier syntax is very much equal to C. Then you can change that -20 and -12. You can notice what is happening. Say, for example, in the same syntax, let me change that. See what is going to happen. The way in which salary is printed, because after printing the second field director, then total field reserved for that second parameter is 20. Now again, one more change you can do it here. Let us try with the 20s of negative minus value. Now look into the way it is printed. Notice the difference. Now, for one particular field, second field, to print the designations, it reserves 20 fields, total 20 character width field, and string is displayed and aligned to the right side. Director is printed and aligned to the right side. If you write a negative, it will be aligned to the left. Similarly, now look into the name. Name is printed aligned to the left. Now I'll make it to align to the right by removing this minus. This also works in C. Remember, you can do this in C also while formatting output. Now look into the output, the way in which output printed. It is right aligned. If you write minus 20, it is the left aligned. Depending upon the type of depending upon your requirement, you can format it. Now I will go for name to print left aligned. Now look into the way in which output is displayed. If you want to direct a designation also to be left aligned, you can do so by making it as a minus 20. B is left aligned. Total if you have any doubts regarding this, you can ask. Sometimes we may give you a format, specific format. In the exams, we may tell you to write a code for it. That time minus 20 and plus 20, what happens without sign, what negative sign, what happens with the negative sign, etc. You need to be aware of these formatting commands. Okay. Then you can also go for look into this and try to analyze what is going to happen. Okay, that command we have here. Director, chairman. Now, so here we got an output like this, right? emp.lst, directors of chairman. In case if I use my original file, emp.lst, this is not working. Okay. With the empn.lst, the same command works. If I say emp.lst, this command will not work. Just check the output, the emp.lst once again. emp.lst contains white spaces in columns. Say some names may be short names, some may be very long names, etc. Then there are white spaces. That is the problem. Within the two delimiters, there is some white space. Whereas empn.lst, that white spaces are removed. This is the same file by removing extra additional white spaces in a column. So look into that's why when we try these commands, a few commands in the last class, we didn't get the output. And similarly, we can go for number comparisons also. Number comparison, we tried it in the previous class. Just also look into this. Say, for example, AWK. It's important in almost all the commands. So that's why formatting a log file is very important, so that system admins can easily write a script. Now, sixth field in our sample data file is salary. We can go for number comparisons also. Then what to do? We can specify in the action field conditions, specify action field. And you can say print. Again, here also you can go for selective printing, selective field printing with the C-like syntax. That you can do it on your own. You can try with that. Within the floor brackets, you can write printf C-like syntax to display the desired fields only. Now I am going to print everything. So this is going to print the employees drawing salary more than 7,500 with the comparison. Now greater than $6 greater than 7,500 print. Now, but just by writing print, every entire line is printed, but you can go for selective printing also. And you can also write numerical expressions also along with this. In the regular expressions also along with these comparisons. $6 in case if you want to print. You can write if the salary is greater than 8,000 and $5, that is the date of birth. Something went wrong here. Let me check. I'm not able to access that input. Actually, this field should access a particular string, the fifth string. That is, I'm not. Let me check what went wrong with this. I'm getting problem in this. Let me check it later. Now I will go to the string part. I will come to that. Come back to you a little bit later. Now coming back to the where we stopped, that printf statement with the comparing the two strings. In the last class, we are trying to get the output with the that particular variables. So this particular problem, I'm not getting it. Let me solve it a little bit later. I will come back to you. Let me go to the next number processing part. Begin and end section. So in the previous initial command, we used some keywords called begin and end. Ability statements are usually applied to all lines selected by the address. And if there is no addresses, then they are applied to every line of input. If you have to print something before processing the first line, for example, a heading, then begin selection can be used quite gainfully. Similarly, the end section is useful in printing some totals after processing is over, this begin and end sections. So the begin and end sections are optional and take the form begin, then you will write flower bracket, write some action, then close it. Similarly, end also. End within the flower bracket, some actions. So then you can both require curly braces. These two sections, when present, are delimited by the body of the AWK program. You can use them to print a suitable heading at the beginning of the average salary at the end. Store this AWK. So we can store the AWK program in a separate file also. We also worked with that by storing one AWK program in a separate file. Say, for example, we can try to get some output. Like the shell, AWK also uses hash for providing comments. You can, if you're writing a long AWK programs, then you can write hash to provide comment. The begin section prints a suitable heading and offset by 2 tabs. You can use the offset also. You can write begin and end in a text file if you're writing any programs. And also note that AWK also supports for built-in variables. There are some built-in variables provided. Built-in variables are also supported for NR for cumulative number of lines. NR, we used it. FS for input field separator. then another environment variable called capital OFS, that is output field separator, NF for number of fields in current line, etc. Also, to the some extent, AWK supports for arrays. Okay, anyway, so up to the built-in variables you prepare for your exam, for your mid-sem exam, even in from the textbook of Sumita Badas, note down, you can study from AWK chapter number 18. In that, you study up to 18.9. Okay, up to 18.9, the begin and end sections. That is the portion for your end sem exams. Any doubts regarding exams? Do you have any doubts about portions? All the portions till SED and AWK 18.9. AWK portion is up to 18.9 only. Any doubts? Now, let us start with the one second. As I said, AWK supports for arrays also. So how this AWK works with the arrays? Now say for example, if you want to create one array, write AWK, then single quote, right, because begin, an action field comes. So within the begin, let's say for example, F, let's take one simple example of something like this. Now look into this, the way I created one array here. Okay, AWK has associative arrays, and one of the best thing about it is the indexes need not to be continuous set of numbers. Okay, need not to be continuous set of numbers. You can use either string or number as an array index. I used string as an array index here. F of mango, F of orange, etc. Instead of telling that F of 0, F of 1, etc. Also, there is no need to declare the size of the array in advance. Array can be expanded or shrink in the runtime. Now look into this, the array name. Array name syntax is very similar. Syntax is array name within the square bracket index. Index can be number or strings. That is a specialty in AWK. To gain more insight, look into this particular code. Let us, okay. On executing this code, we are getting orange and yellow. So look into f of mango is equal to yellow. F of orange is equal to orange. I changed the spelling also orange there intentionally. That doesn't matter. Okay. Mango is the index. O double R A N G is the also index. Yellow and orange is the value stored in it. Then I am printing f of orange, and in the next line I am printing f of mango. You're going to get that particular output. Similarly, if you want to delete any array element, we can write a command called delete also. How to delete one element? Now look in, for that also you can write a script awk delete one element from the array. You can go for single quote and you can write begin, indicating the starting point. Then, if for example, if let me use this string variable as a index equal to hello one element, and the second element. If you go, you can go on typing in the next line also. You will get that greater than symbol as a starting at the starting point. Don't worry, you can continue. Now you can write delete f delete command to delete that particular index number. Now look into the output here. I assigned orange to or f of orange, and after that I deleted that array element. F of orange is deleted. Then it gives no output. It's how one array element can be deleted, creating one array, and also you know how to delete one array. Similarly, multi-dimension array is also supported. Okay, multi-dimension array is also supported in AWK. Say for example, we can type AWK, and again we can start begin, declaring array elements. Look into the array name A within the square bracket. Within the double quote, you can write index element is 0, 0. And you can store values in it. Any, for example, if you say 10, and you can say the element in that row is 0, 1. Say, into array I'm going to try 1, 0. Is equal to 30. This array can be assigned. All the array elements are assigned. To print that array element, you can print individual array elements also. In case if you want to print one particular array element, print array of 1, 0. This is your formatting the output. Then write equal to the value stored in 1, 0. Now it is a double quote here. This is accessing actual values. Then write semicolon. And in case if you want to print one multiple values, you can print. Otherwise, you can end the code. Array 1, 0. Array. What went wrong here? Sorry, I should not write array here. It is array name is A. You are going to get the array element. Whatever I have written here in the code, say AWK begin, I'm assigning for the first element in the row is a 10, second element in the row is a 20, and in the second row I have 30 and 40. After that, I am printing the value. I wanted a formatted output. That's why I want this message. Output is array 1, 0. Then I want to print array, actual array name is A. I want to print 1, 0th element. This is how array element can be accessed. Then write the semicolon, flower bracket. This is the output. Output of this script is one element of the array. This is how you can access array element using AWT script. Your own programs using arrays and how to add multiple array elements, row elements, column elements, etc. Now you know how to access individual element. Using the same notation, you can process the number stored in it or strings stored in it. Anyway, for the array will start the midterm examination. Till this particular point, arrays are not included. Remember that arrays and functions are not included for the discussion. The rest of the portions, whatever so far cover, is included for the end-sem exam. If you have any doubts, you can ask me now. Similarly, while preparing for the exams, if you have any doubts, feel free to send your queries in MS Teams. I will reply. Even while you are writing initial script, if you go with some errors, send me the code as well. I will look into it. Any doubts? If you have any doubts, you can ask, raise that question now. Otherwise, we'll meet in the next session. I think next class will be after the mid-sem examination. And also look into the pattern of the examination. You will get question number 1, question number 2, question number 3. 2 mark questions. Okay, total 6 marks. Then 4 and 5 questions are 3 mark questions. Question 4, question 5 is the 3 mark questions. Yes. Last 2 questions are of 4 marks each. You will get descriptive questions as well as shell programs. This is about question paper pattern for the end-sem exam. That's it. If you have any doubts, you can ask me. You have 1 minute.
Sir, portion.
Portion, that's what I mentioned. Till today, whatever I covered, that is included except arrays. From the beginning. From the beginning of this entire class, shell programs is a midterm examination. Remember that. Entire portion is included. Any queries? Okay, then we'll see you in the next class. Bye for now.